We're going to take a look at solving by completing the square. And what we're doing is we're going to solve these quadratic style equations. And if you remember from your algebra past, you've learned how to solve these things by graphing, by factoring, by square roots, by quadratic formula. And we've so far skipped completing the square. But this is the fifth way, the fifth possible way to solve a quadratic formula. Tie your shoes because it's going to get wild. I'm going to quickly run you through the first time you've ever seen this, and the first time you ever see this, it's going to seem crazy, but then you're going to learn this technique. So here's my original equation, and the very first thing I do is I take that 32 and I move it to the other side. Then I go ahead and I find the coefficient on the x, and I say that's a 12. I'm going to multiply it by a half or divide it by 2. Either way, half of 12 is 6. And then I'm going to take that 6 and square it and get a 36. That 36 goes on the left side and the right side of the equation. There it is. So this equation turns into that. And of course these two add to 4, so I just rewrite the left-hand side and turn that into a 4. Then I say, hey, wait a second. This thing can be factored. Since the leading coefficient is a 1, I simply ask myself, what two numbers multiply to 36 and add to 12? Of all the numbers that multiply to 36, only two of them add to 12, and that's 6 and 6. So my brain would be thinking about the pair of numbers 6 and 6, and that means I factor this into that. Well, x plus 6 times x plus 6 is x plus 6 squared. So I just take that and I rewrite it. Notice that I'm just recopying the right-hand side and I'm being very meticulous. At this point, this is something I can solve. When I have x plus 6 squared, if I square root it, I'll kill the squared. If I square root the left, I square root the right. So now I get x plus 6 equals plus or minus 2. These are the steps we learned when we were doing solving by the square root method. When I square root in an equation, I need the plus minus. Well, if I have plus minus, then when I move that 6 over to be a negative 6, I still need that plus minus, which just means I do negative 6 plus 2, negative 6 minus 2. And these are my two answers to that equation. Now, of course, that went very fast, and you're wondering, what the heck is going on? Well, we're going to go through it a little bit slower, and I'm going to give you a list that you can use, but the bottom line is you're going to have to practice this procedure, and as you practice the procedure, then it becomes less mysterious. The sheet you're looking at right here is available for you on the lesson plans, and I'm going to take the exact same problem, but now I'm going to have the steps that I'm doing written out so you can follow those steps. So the first thing I do is I arrange the equation to get the constant term by itself. That's the constant term. I move it to the other side. A plus 32 means I do minus 32 to each side. But now this equation looks more like this, and I'm purposely leaving this awkward space there, and you'll see why in the next step, or in a couple of steps. Now I find this coefficient. It's the coefficient of the first degree term. Remember, that is an exponent of 1. And that coefficient 12, I now multiply by 1/2, and then I square it. So I'm just following these steps. That result gets added to the left and to the right, or both sides of the equation. So add the result from step 3 to both sides of the equation. So there it is. There it is. These two numbers can simplify. Once I have this equation turned into this form, I can now say, hey, this factors. It's a leading coefficient of 1 style factoring. What two numbers multiply to 36 and add to 12? That's what I'm thinking to myself. So this factors into that. Once I have factored form, I can rewrite the left side to be squared, because the way these problems are going to work, this is always going to be this type of coincidence where it's something times itself. Something times itself can be written as a squared, And from here, you can solve that equation with the square root steps that you've learned in other methods. Square root both sides. Don't forget the plus minus. Move the 6 to the other side. Don't forget the plus minus. And now it just means I go two different paths. So no doubt this seems overwhelming in the beginning. But if you're using this checklist and working the practice problems and checking your answers, you're going to do just fine. But it does take practice, like many things in life. We'll go through this one last quick example, and I'll leave the checklist on the side. Arrange the equation to get the constant term by itself. So this is a constant term and this is a constant term. These are variable terms. I need that 2 on the other side. Boom. I move it over there by subtract 2. Find the coefficient of the first degree term. Well, there's the first degree term. It has an exponent of 1. And then multiply by a half and then square it. So I have to take that 8, divide it in 2 or multiply by a half and then square it. So half of 8 is 4, 4 squared is 16. Then once I get that 16, add the result to both sides of the equation. So remember, I left this awkward space. The 16 is going to go there, and if I do 16 added to the left side, I have to do 16 added to the right side. So there that is. Once I've done that, I'm now down to step 4. No, I'm not. I'm down to step 5. Factor the left-hand side. This is very factorable. It's a leading coefficient of 1 style factoring. So I say what two numbers multiply to 16, but also add to 8. That number is going to be 4. And you're going to start to notice patterns about these problems. So this factors into x plus 4 times x plus 4. And then it says rewrite the left side to be squared because x plus 4 times x plus 4 is really x plus 4 squared. At this point, the last step just basically says solve the equation using the square root steps that you know. And you can take it from here, square root both sides, and don't forget the plus minus, and now you just follow those two different paths. So it's a pretty clunky process, but it'll get you the answer. It'll get you the same answer as if you were using any one of these other methods. It's just a new and final method. And you might say, why the heck are we learning that? Well, as you move on into possibly in geometry, but for sure in Algebra 2, you'll need this for other parts of the math world.